This video is on the periodic table. So our periodic table is broken up into parts. We have different types of metals and nonmetals, and we have metalloids as well. So our rows on the periodic table are called periods, and they're labeled or numbered 1, 2, 3, 4, 5, 6, 7. So these are your period numbers. And we have columns on the periodic tables, which are numbered 1, 2, we're going to skip the transition metals, 3, 4, 5, 6, 7, 8. So these are column numbers. And items or elements that are in a column have similar properties. So just write that columns have similar properties. Our columns have similar properties because our valence electrons are the same for all elements in a column. So any element in column 1 for valence electrons has 1 valence electron. In column 2 they have 2 valence electrons. Column 3 they have 3, 4 they have 4, 5, 6, 7, and 8. And this has to do with where their electrons are in the highest energy level. So any electron in row 2 or group 2 would have 2 valence electrons in that s orbital. So columns are also called groups. Sometimes they're also called families as well. On our periodic table, we have a dividing line, and our dividing line runs here and comes down, over, and down. So it's a zigzag line. This zigzag line is called the Amphoteric Line, and it's the dividing line between metals and nonmetals. So this is our amphoteric line, and it divides metals and nonmetals. To the right of this line, so here and right, we have nonmetals. And then here and all the way to the left, all the way across, are our metals. Our different metals and nonmetals, some of them have specific family names. With our metals in group 1 metals are called alkali metals. Group 2 are alkaline earth metals. Our middle metals here, from here to here, and they come straight down through here. These are our transition metals. Our nonmetals have fancy names as well. Group 7 nonmetals are called halogens. And group 8 nonmetals, we've talked about once already, are noble gases. These are completely inert. So noble gases are inert. They're not going to react with anything. Halogens, these are very reactive. And they're really the most reactive. Nonmetals, abbreviate nonmetals NM. Similarly, alkali metals are the most reactive metals. On this dividing line, we have elements that touch 2 of the lines, and we have boron as well. These are not considered metals or nonmetals. These are considered metalloids. In our transition metals, we also have something called inner transition metals. So you notice on your periodic table, these 2 boxes don't actually have elements on them. That is because here we really insert this whole line of inner transition metals. The reason that we take this chunk, these inner transition metals, and write them down at the bottom is because if we were to put these here, the tables wouldn't fit real well on a sheet of paper. So because of that, they've gone ahead and said, okay, I know these are here, but we're going to pop them down. You notice that our numbers jump from 56 here to 72 here, and that's because this whole box, this whole line should really go here. Our metals, metalloids, and nonmetals have different properties, and that's based off of their electrons. Metals are solid at room temperature. They have luster. They're malleable and ductile. Ductile has to do with turning into a wire, and malleable is being pounded or formed into a sheet or other shape. They conduct electricity, and they have high melting points and boiling points, which has to do with being solid at room temperature. Metalloids are also solid at room temperature, and they're used as semiconductors. So in a lot of your cell phones or laptops, Chromebooks, semiconductors are used, and we're able to shape them and mold them. They conduct electricity real well, but then we can also put them in different situations where they don't conduct electricity, and that's why they are a semiconductor. So sometimes they do, sometimes they don't. Depends on the environment. And then lastly, we have nonmetals, which are ones over here on our periodic table. These are liquid or gas at room temperature. They don't have luster. They're dull. They're brittle, so if you try to break them, they usually crack. They don't form into different shapes. They're poor conductors, and they have low melting points and boiling points. So when I have to think about my different properties of metals, metalloids, and nonmetals, I like to think of examples. So like your nonmetals are going to be your gases. So I think of one of the elements on this side table. So usually think of like oxygen gas. A metalloid, I think about something like silicon. And then metals, I usually think about something like copper.